Hi everyone, in today's lesson we're going to go through multiplying and dividing surds, and so in particular we're going to be looking at multiplying two surds. When we've got two surds, we've got our whole numbers and our surds, as well as then dividing surds division, and in particular the harder ones which are using distributive law, so when we're expanding brackets, but expanding brackets with surds. Okay, so now just one thing, when we do get to that, it might be worth noting right now that if you have the square root of, let's say, 3, if I have the square root of 3 times root 3, what would that be? It's 3, isn't it? Okay, the square root, in other words, if I was to have the square root of 3 squared, you know, students ask, why is that? Well, the square root of 3 squared, the squared and the square root sort of like cancel each other out. They're inverse operations of each other. So if you like, the square root of 3 squared is 3. And then, of course, that goes the same for anything else. So the square root of 7 times the square root of 7 is 7 because the square root of 7 squared, technically the square is the inverse of the square root, and they cancel each other out. So, of course, that would be equal to 7. Now, because likewise, I could ask you this. If I was to ask you 2 root 3 times 2 root 3, then the easy way to do this, some students can get mixed up a little bit, but what we do is let's do 2 times 2. Let's do multiply the front. 2 times 2 is 4. But root 3 times root 3 is what? Root 3 times root 3 is 3. So, in actual fact, 2 root 3 times 2 root 3 is 4 times 3, which is 12. Now, let me show you again. Let me talk you through it. 2 twos are 4. So we're actually calculating now. I don't have to explain why 2 twos are 4. But, of course, what you can do is you can do this calculation here. I won't swear on YouTube. That's a good way, sure way of getting fired. But root 3 times root 3 is 3. And can you see there, by breaking it up into two separate problems, making our life a little bit easier, if you can recognise that root 3 times root 3 is 3, and we know 2 twos are 4, then this is going to make your life a lot easier. That's why I'm sort of sitting there talking about this to begin, because that's what I think if you can grasp those concepts and bring those two together, then you're going to have a good time with things. Just recall, of course, when we've got the two square roots multiplying, these are equivalent, so I can multiply x, y. So those two things are equivalent. And likewise with fractions, I can split that up. The square root of x over the square root of y is the square root of x over y. Okay? We might as well just get stuck straight into some problems, and we're going to go through some of these. So when the square root of 2 times the square root of 3, simplifying it, well, of course, we're looking for perfect squares, but the square root of 2 times the square root of 3, we're simply just doing 2 times 3, which is 6, and it's the square root of 6. Now, the question is there any perfect squares which goes into 6? No. So we're looking for 4, 9, 16, 25, 36, and so on. If you can simplify, then please do, because in this one, let's do this together. First of all, 2 3s are 6. Okay, so 6. And of course, we've got 3 times 15. So we can go 3 times 15, and that's going to be 6 root 45. Now, in this one, can we simplify? Can we simplify? Root. So hopefully you recognise that yes, 45 has a factor which is a perfect square, which means 9 goes into 45. So we can actually, we're not done. When we get to this step over here, unlike when we had the square root of 6 and we stop, well, here we can keep going, can't we? Because 6 root 45 is 6 root, well, the 6's stays the same. That's 9 5s are 45. And the square root of 9 we know is 3. So 3 comes out the front. 6 3s are 18. So that's going to be 18 root 5. Can we stop there now? We done now? Yes, we are. It's a prime number. The only factors of itself and 1. So we know that we can stop there, 18 root 5. A lot of time as well, this can trouble students, but remember, just write it out like this. 2 root 5 squared is the same as 2 root 5 times 2 root 5. You don't even need the bracket there. But of course, let's do that. 2 times 2 is going to be 4. And what's root 5 times root 5? Root 5 times root 5 is 5, just 5. It's the square root of 25, indeed, James. But it's the square root of 25. You can also do it that way, which of course is 5. So that's going to be, so we've done 4, we've done that. Let's do that. The square root of 5 times square root of 5 is 5. So that is 20, and of course we can stop there. All right, now if you are watching at home and we've been through these, can I get you, and I'll get everyone in class now, to have a go at these ones, and we're going to go through it. So if you're watching this at home, pause it now and give these ones a go. I want you to have as much time. So let's go through this really quickly. Like before, root 5 times root 3 is indeed root 5 times 3, which is root 15. And because 15, there are no perfect squares, 4, 9, 16, 25. None of those go into 15, so we know we can stop. So we're done there. Likewise, when I do this, let's multiply the numbers out the front. Just like we do in algebra, you multiply your 2's and your 3's before your A's and things like that. 3 4's are 12. But what we've got here is root 2 times root 6 is root 2 times 6, which is going to, so we've got 12, root 12, but we can't just simply stop there because 4 is a factor of 12. 4 is a perfect square. We know that we can rewrite 12 as 4 times 3. Or of course, if you want to write it like this, that's okay as well. 4 and 3, you can break it up like that. And of course, the square root of 4 is 2. 2 12s are 24. So our answer is 24 root 3. Okay, did you get that, Hamish? Very good. Now, what do we do over here? When you see 3 root 7 squared, it's multiplied by itself 2 times. Likewise, you could be asked for it to be cubed. If it was cubed, it would be multiplied by itself 3 times. Oops, why did I write 3? It's just been a long day. There you go. So let's rewrite that. Now, 3 3's are 9. 3 3's are 9. So let's do the numbers out the front first. Root 7 times root 7, though. Hopefully you're getting the hint that root 7 times root 7 is the same as root 7 squared. Square and square root cancel. We're left with 7. Or if you do it the other way, 7 7's are 49. The square root of 49 is 7. Okay, so either way you want to do it, that's okay. So 9 7's finally are 63. Hands up if you got those right. Good, well, we're doing well. Now, okay, we have more time. What about over here? I've got minus root 10 on root 2. I've got something like that. How else could we rewrite that? How else could we rewrite it? We could write it as 10 divided by 2. Let's do that. We could rewrite it like this, okay? So that goes back to our rule that we're looking at the start, goes back to this thing over here. So you need to be able to identify as a fraction, those two are equivalent to each other. So minus root 10 over root 2 is the same as minus square root 10 over 2, which of course is simply just minus root 5, and we're done. Okay. Likewise over here, we've got to simplify. We've got to simplify 2, but let's do this as this. First of all, I've got 12, and I've got a 3, but the square root of 18 is, well, let's do that as what? Yeah, we've got that as, that's going to be 9 times 2. Highest perfect square is 9, which goes in 18. If you did things like root 3 and so, like you could have, by the way, I'll show you 2 ways to do this, but of course, we generally, when we're simplifying, we want to look at the perfect squares. So we've got this, bless you, Now over here we've got the square root of 9 is 3. 3 comes out the front, so that's going to be 12 times 3, which is 36, root 2. And then we've got 3 like so. And 3 goes into 36 12 times. There's actually going to be two sort of answers to this, but for the time being, we'll sort of show you that that's going to be, 12 would be 3 goes in 36 12 times, and there's a root 2 and root 3. We're going to actually look at later, though, we're going to be looking at what we call rationalising this denominator. We want to actually, a lot of the time, we want to do what's called rationalise. Now, we talked about square roots being irrational. Square roots are irrational. We look at, like, if I look at the decimal places, 1.41, blah, 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 and there's no sort of repetition in these, this is what we call irrational. So these surds, these square roots, are what we call irrational. So later on, we're going to be looking at rationalising that. So you might see, sometimes when you look at the answers, you might sort of see that there's not a square root on the bottom. So when they're doing that, we're going to talk about that a little bit later. Another thing you could have done is so even though this looks a little bit different to this, we could have also done this. We could have done 12 over 3, but let's split that up as to 18 divided by 3. Okay, 18 divided by 3. And 18 divided by 3 is 6, isn't it? So it would be 12 over 3. That would be now a 6. 3 goes into 18 6 times. And 3 goes into 12 4 times. So 4 root 6. In actual fact, these two things here are actually the same. They just look different. Okay? We're going to talk about rationalising the denominator a little bit later. In fact, I'll show you. This is something that, by the way, we are doing in another lesson, but I might as well show you that these two are actually the same. I'll show you why that is. If I have 12 root 2 on root 3, when we're trying to what we call rationalise, and let me just highlight that for you, if I'm trying to rationalise the denominator, I'm trying to make that rational. Now, when I say rational, 3, which is a whole number, can be expressed as a fraction. That's rational. So what do you think we could do to root 3, to make that a whole number? What could I multiply it by? Root 3. And if I multiply the bottom by root 3, what do we have to do to the top? We're going to have to do the same thing. Otherwise, we've created imbalance. Now, let's see if that is indeed this thing over here. All I'm doing is I'm multiplying the bottom by root 3. What we're doing is we're rationalising the denominator, making it some number which isn't a surd, square root. Let's do that. Can you see that when I multiply across 12, well, that's 12 times 1 is just 12. Can you see there that root 2 and root 3, root 2 times root 3 is root 6, and root 3 times root 3 is what? Is 3. And, of course, 3 goes into 12 4 times, doesn't it? Can you see there that those two are the same thing? See how we got that over there? Even though they looked a little bit different, sometimes you might even check your answer, and because you haven't rationalised it, a lot of the time the answer in the back of the book will be this rationalised answer. We're going to go through that a little bit later, but I thought I'd give you some exposure to it now. Okay, so there you go. Dealing with fractions, no different. Nothing too crazy about that. Let's have a look at some of these, though, because this is, of course, what troubles some of you is when we're using distributive law to expand brackets. So let's break this up. What we're doing is if I've got root 3 out the front, we've got to multiply these two terms, and then I've got to go over here and multiply those two terms. Bring them all together, simplify. If you're at home, why don't you try these now? I'm going to ask my students in here to try this one now. See if you can do it. I'm going to go through that in a few minutes with you. Zoom now. So with this first one, I've just broken it up into two problems. Hopefully you can see, and there's sometimes trick students because really when I've got root 3, that's 1 root 3. So what we're doing is we're multiplying the numbers out the front. 1 and 3 is 3. And then we're doing, likewise, we're doing root 3 times root 5 is root 15. Now, we can't simplify that any further. because 3 root 15, no perfect square goes into 15, so we're done. And then, of course, this one, we're looking at root 3 times minus root 6. Be careful and make sure you take the sign out. 3 6s are 18. But of course, negative root 18 can be simplified. 9 2s are 18. 3 comes out the front, so it's minus 3 root 2. So therefore, our answer to that is when we bring those two together, and we can say that our answer to that is 3 root 15. Take away 3 root 2. That's our answer. And of course, we can't simplify that because root 15 and root 2, they are two separate things. They're not like terms. We're done. Okay. Likewise, over here, let's do this one. And we'll try to do this in the 2 steps. First of all, let's do the first one. 3 2s are 6. And 6 10s are 60. And by the way, I'm going to write 60 for the time being, but we're not quite done yet because we can find a perfect square which goes into those. So we've just done the first one. If you want to do that in one line, that's okay. If you want to break it up, that's also okay. But I think that we want to probably get in the habit of using equal signs and setting out your work like so. Sometimes some students can be a bit messy and have things all over the place. Now, 3 4s are 12, so we've got and minus 12, like so. That's minus 12. What is root 6 times root 6? What is root 6 times root 6? It's the square root of 36, which is actually, so it's the square root of 36, which is 6, isn't it? So over here, what you've got to get good at is doing this calculation where it's root 6 times root 6 is 6. 3 4s are 12, so that there is going to be minus 12 times 6. Now, what is the biggest perfect square? What's the biggest perfect square which goes into 60? 15 and 4. So 15 times 4 is 60, 4 being our biggest perfect square. And of course, 12 6s are 72. You should hopefully know that. And of course, the square root of 4 is 2. 2 comes out the front. 6 2s are 12. So we're looking at 12 root 15 takes 72. And again, that is our simplified answer. We know there that we can't simplify. We don't have any whole numbers to collect. And our surds or square roots, there's nothing there to simplify any further. Okay, let's go through this one really quickly. Now, if you are watching this, you please give these a go. But I'm going to, in a second, go through this one to finish off. Again, break it up into 2 problems if you like. But I think that if you can start setting out your work like this, where we go from one line, this here being the first calculation, 3 2s are 6, and don't simplify it at first. Just get it down like that so you can see there, that's your first calculation, that's your second calculation. If you can get in the habit of doing it like this, you're going to get better and better at setting out your work. You're going to confuse yourself less. As opposed to, I see a lot of students that sort of break it up and they have it all over the joint. I think that it's better to have it as an equation like in this second one. All right, have a go at this now, and we're going to go through the answer shortly. All right, I'm going to go through this really quick. Again, you can break it up. You can break it up like this, but I would prefer you to get in the habit of doing it as one equation in one line. So the first expression here, we're going to do these two. Remember that and a lot of students forget that there's a 1 out the front. Okay, so 1 times 5 is 5, and that's going to, so if I'm going to do, that's going to be 5 is the whole number. Root 2 times root 3 is 6. So we've got 5 root 6 is this first one expanded, and then the second one expanded, we've got a 1 out the front, is going to be 7 times 2 is 14. And we can't go any further because 6 and 14, they have no factors of perfect squares. So we're done. You don't have to do anything more. For the next one, 5 times 2 is 10. And root 3 times 6 is root 18, but we can simplify that. Now, let's do the next one. I'll rub it out because it's a bit busy at the moment. 5 threes are 15, so it's minus 15. And again, root 3 times root 3. The sooner you realise, you break it up into two problems. And 5 threes are 15, but you're not done yet because you've got to multiply 5 threes by the square root of 3 squared, which, of course, hopefully you're identifying that is what? 3. That's right. It's 3. 15 times 3 is 45. So we're not done yet. 9 twos are 18, and that's 45. So our answer is 30 root 2 minus 45. Okay?